Right now we're going to talk about a kind of an important reaction in this chapter. It's another example of alpha addition. It's called the aldol reaction. And when you look at the reaction I have shown on this page, it's kind of, well, we said it was an addition reaction, it's kind of what it is. You have something with a carbonyl in it, usually an aldehyde or a ketone. Let's stick to aldehydes and ketones now. And in the presence of a base, OH minus for example, you can have a reaction known as an alpha addition or an aldol reaction. The name aldol simply comes from the combination of the words aldehyde and alcohol. Push them together, you get aldol. However, it's kind of a misnomer because it doesn't just work with aldehydes, it also works with ketones as well. Alright? And the product that you always get is one that looks like this, where you have a carbonyl group and an OH, 1, 2, 3 carbons away from each other. Alright? So you could essentially say you have a beta hydroxy carbonyl. So a beta hydroxy carbonyl. I say carbonyl because it could be an aldehyde or a ketone. So, okay, so don't think that this only works with aldehydes, because it works with ketones just fine, right? Now you might be wondering, well, how does this happen? Seems a little odd. Well, no, it's not. It's really exactly the same as what we've seen before. We need something with alpha hydrogens, and in this case, notice that there are two equivalents of the molecule here. We don't always need this two. We'll get to an example of one we don't have that here in just a minute, but let's look at this one first. The idea is you have a molecule that has at least one alpha hydrogen. Okay, and you have a base, in this case OH minus, and we're going to do an example of this in the lab here very soon. The OH minus grabs the acidic hydrogen and forms the species that we all know its name of, and that is, wait for it, what is it? It's the enolate, of course it is. I knew you guys were all going to say that. Here is our enolate. One of the last videos we talked about the concept of direct alkylation, where you just send the electrons down and out to an alkyl group. But what if you have another one of these molecules present? So what we have here is this OH minus is really only added in a very small amount. Catalytic. Bollocks, I can't spell this. You only need a tiny amount of it, basically. Because as the reaction goes on, more and more gets generated. In fact, formation of this is not all that favorable, and for that reason all these steps are in equilibrium. So even though this isn't very favorable, because this isn't quite a strong base, occasionally it does happen, and then once this reaction starts going, it pushes the reactions toward the products. So let's see what happens here. The O minus goes down there, and the electrons from the pi bond and the enolate go out, and they will attack something. Now, what is that something in this case? Well, it's the most electrophilic carbon, same as it's always been. So that most electrophilic carbon, of course, is the carbonyl carbon, which pushes those electrons up onto the oxygen. Now, this is where we got to be careful with the aldol reaction, particularly when we have molecules that have a large number of carbons, and I'll do another example of this here in just a minute. It's really important to make sure that you count your carbons. Okay? Now, to make sure I don't forget this, there should be a hydrogen there, and there should be a hydrogen here. Alright? I'm going to number the carbons in my enolate as 1 and 2. I'm going to number the carbons in my second molecule of aldehyde as 3 and 4. So when I draw out the structure of my enolate once that reaction's occurred, here we go. We've reformed the carbonyl, we have reformed that carbon-carbon single bond, But notice now, if I draw on carbons 1 and 2, and I ask you guys which carbon out of 1 and 2 was the nucleophilic carbon, well, it's like it always was, it was carbon 2. And which carbon has carbon 2 bonded to? Well, hopefully you'd say that's carbon 3. So I'm going to draw out 2 more carbons. Those are going to be carbons 3 and 4. Alright? Except the difference here is now on carbon 3 we have an O minus. But what else do we have that we generated very early on? Well, we have water. So here is our water. Best looking water molecule around. And what's that O minus going to do? Well, not a surprise, it's going to grab the hydrogen. It's actually going to form the aldol reaction product and regenerate the catalyst. So if there's more aldehyde around, the reaction will just start all over again. So let's draw this out. The product here then is going to be this, except now there is an alcohol here. Alright, in this case this would be butanal, so this would be 3-hydroxybutanal. Oh crap, yeah, that's right up there, isn't it? Okay, anyway, the important thing is, if this is the alpha carbon, this is the beta carbon, and notice that the alcohol is beta to the carbonyl. If you go through a mechanism for the aldol reaction, and make sure you take a note of this, this is key. If you go through your mechanism and you find that in your product your alcohol is not on the beta carbon relative to the carbonyl, stop and go back, because you've messed up somewhere. It's absolutely key. Alright? So it's a really good way of telling yourself, oops, I ballsed it up somewhere. Perhaps not ballsed it up, but you know, you messed it up somewhere. Anyway, that's the mechanism for the aldol reaction. It's really very simple, but it's one of these ones where if you don't count your carbons carefully, it can get rather complicated. Right? Let me just give you an example. Let's move on. And let's just do exactly the same thing again. But let's say I do this. Alright? I'm going to do the same thing. And just to make it more interesting, I'm going to put some more carbons up there. And we're going to do the same thing. We're going to have some OH minus here. So first off, where is the alpha hydrogen? Well, the alpha hydrogen is right here. Are there any other alpha hydrogens? Of course, the answer is no. Here's our OH minus. For some reason I've drawn it in red, I don't know why. So that goes up there. Exactly the way we've seen before, this grabs one of the acidic alpha hydrogens. Now bear in mind, I drew 2 here. Only one of these is actually reacting right now. The other one will come along here in just a minute. We've generated our enolate. La-di-da-di-da. There is our enolate. You having fun yet? Of course you are. It's organic chemistry. There's no such thing as not having fun. Alright, I'll shut up. Okay, so we've generated our enolate, and we have our second equivalent of our aldehyde. Well, why don't we try this? Let's send the electrons back down. Send the electrons out to the carbonyl group and kick them up onto the oxygen. This in itself is fine, but the problem we're going to run into now is, oh my god, am I going to get myself all messed up with counting my carbons? Well, the answer is very possibly yes, if you're not careful. So to be careful here, let's number these 4 carbons, 1, 2, 3, and 4. And then I'm going to number these carbons. And remember, I'm just numbering these arbitrarily so we know what's going where. I wouldn't normally start off an aldehyde on the aldehyde carbon with the number 5, just in case anybody's being particular about it. Alright, so let's try and draw out our product. And I always like to draw out the product starting from the enolate carbon after you reform the carbonyl, but it's totally up to you as to how you want to do it. Just bear in mind that the product I'm going to draw out is going to look rather different from these 2 added together. So let's just start off. Here is carbon 1 with the hydrogen on it. Alright, and I'm going to draw out carbons 2, 3, and 4. Okay. Uno, dos, tres, catorce, as you two would say in How to Build an Atomic Bomb. Of course, it's not really that. It's cuatro. So, carbons 1 and 2 here, they are the carbons in the double bond. You know it's carbon 2, what was the nucleophilic carbon, and that bonded, can you guys see, to carbon 5. So when I draw my bond down here, this is the new bond that I've formed. It's formed to carbon 5. Now this is where you have choice about how exactly you want to draw the structure out. It doesn't really matter. I'm going to put my O minus down here, but I really could put it anywhere as long as I draw it coming off this carbon. And I'm going to draw out the rest of my group here. I have this, and then what else do I have there? I have my hydrogen. Alright. So let me just number these as well, so we all know where we are. 5, 6, 7, 8. Okay? And then all we do, right at the end, is we just take the water that we generated in our first step and just do this. Alright, now let me just draw this out and then we'll be done with this. I'm drawing out exactly the same product again, except now the O minus is an OH. So this is an alcohol. Now take a look at the alcohol compared to the carbonyl. They are beta to each other. And that tells me, dude, I've done this right. I really do know what I'm doing. And like I said before, you've regenerated your OH minus, so the reaction just carries on. That is the aldol reaction. Alright, that's it.